All right, ladies and gentlemen, our last topic is going to be on scientific notation. Now, if you want to, you can write your notes on the back of your classwork, which is day 1 scientific notation. But this is going to be your homework for this evening. Scientific notation worksheet. 8 questions where you're going to convert a standard notation number to the scientific notation. And then 9 more questions where I'm going to convert the scientific notation to standard. But before we can get to going back and forth, we need to figure out what is scientific notation. It's a way for us to simplify very large and small numbers. A very large number that we are going to be working with, probably by February-ish, is going to be Avogadro's number. Now, you don't have to write down Avogadro's number, but I want you to see the type of numbers you guys are going to be working with. 602, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 atoms or molecules. Avogadro's number is a shorthand way for me to count the number of atoms or molecules in 1 mole of a substance. That's just one of the very big numbers that we're going to be working with. But in chemistry, we also work with incredibly small material too. At the heart of the simplest of atoms, I will find a proton and a neutron bound together, an electron jumping from place to place around it. Now, we have theoretically weighed out the weight of 1 proton. That is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 369 pounds. That is the theoretical weight of 1 proton in an atom. We're talking about incredibly large numbers, incredibly small numbers. Imagine if every time you had to do some kind of mathematical calculation in this class, and you will be using this one from time to for a good part of the second part of this year, you had to type in 19 zeros. There's a very good chance at some point you're going to make a mistake. How do I get around this? How can I rewrite my number so it's easily digestible to me as a scientist? I'm going to use scientific notation. So, to help me out here, I want us to take a look at our page here. Day 1 scientific notation. So give me the step-by-step to do it. We're going to do a couple together, and then I'm going to have you guys do a couple by yourself. In chemistry, we use very large, very small numbers. We use scientific notation as an easier way to represent these numbers. We're going to rewrite our number by a power of 10. So basically, I'm going to have some kind of number times a power of 10. Now, if I have a big number, I'm going to have a positive exponent. So these are my big numbers. If I have a small number, I'm going to have a number times a negative exponent. times 10, so a negative exponent. So my very small numbers, these are any numbers less than 1. My very big numbers is pretty much anything bigger than 1. Now, on a quiz, I'm going to ask you to what are the 2 parts of scientific notation. No, I'm not going to expect you to tell me what the mantista is, or I will expect you to write down the power of 10, but I'm not going to ask you that specifically. I'm going to say, hey, take this number, convert it into scientific notation. Or, hey, take this scientific notation number, convert it back to standard. These are the types of questions I'm going to expect from you, and you can expect from me. So, the first thing we're going to do is that we're going to find our decimal, and we're going to move that decimal to after the first sig fig. That's going to create a new number that's going to be somewhere between 1 and 10. We're going to count how many times we moved that decimal, and that's going to be our power of 10. I do have a pretty red image here that might help us out a little bit. Perfect. Here we go. So, if we're looking at a way to kind of visualize where things are going, if I have my decimal here, and if I'm moving my decimal to the left of my number, I'm saying I have a large number. That means that my exponent is going to be positive or negative? Positive. Exponent is going to be positive because it is going up. If I move my decimal to the right, am I dealing with a small, large number or small number? Yellow. I will send her down right now. No problem. Bye. Susanna, early dismissal. You're going to catch the video on this later, okay? If I'm moving my decimal to the right, do you think if going to the left with a large number, am I dealing with a large or small number over here? Small number. If I'm getting a small number, my exponent was positive over here, where do you think my exponent's going to be over here? It's going to be negative as it's going down. So I can use this kind of map in order to see which way, how I want to write my power of 10. But either way, whether I'm dealing with a very large number or a very small number, I'm going to move my decimal until I put it behind my first sig fig. It's always the same case. The only difference is times either 10 positive for a big number or times the negative exponent for a very small number. So I'll take a look at my sheet here. Let's look at number 1 together. Oh, it doesn't help that you can't see it. That's all right. Number 1 is 0.005. Are we saying this is a big number or a small number? Small number, right? It's less than 1. So I want to find my decimal. So does everyone know what is a decimal going to be on the right-hand side or the left-hand side? Left-hand side, right? Right here it is. Huzzah! I have found the decimal. Now, what I'm going to do is I'm going to take this decimal and I'm going to move it digit by digit until I create a new number that's between 1 and 10. I put that decimal behind the first sig fig. How many sig figs does my question have? 1 sig fig, right? I will move that decimal over. 1, 2, 3. So now I write my new number. 5. It's always to a power of 10. How many times did I move my decimal? 3 times. Did I move it in the positive direction or the negative direction? Negative. Done. Let's look at number 2. 5,053. Am I dealing with a big number or a small number? Big number, bigger than 1, so I count as a big number. My question to you, where do I find the decimal in 5,053? Behind what number? Behind the 3, right? Because the 3 is in the 1 spot, right? You got 1 spot, 10 spot, 100 spot, 1,000 spot, right? So always behind the 1 spot is my decimal. I can always just put a decimal there if there's not one there, for the purpose of me moving it. So if I move my decimal over 1, 505.3, is that bigger than 1, smaller than 10? 505.3, is that bigger than 1, smaller than 10? No. Keep going then. 50.53, is that bigger than 1, smaller than 10? All right, so I keep going. 5.053, bigger than 1, smaller than 10? Perfect. 5.053 times the power of 10. How many times did I move the decimal? 3 times. Positive or negative way? Positive. So I'm done. That's it. I want you to take a stab at number 3. Number 3 is 0.0008. I want you to move that decimal so it's behind the first sig fig. I want you to take your new number, multiply that by a power of 10. If I move to the right, or did I move to the left? You want to tell me what the power is. One, two, three. When you guys have figured out your power of 10, I want you to write on your whiteboard. You're going to show me what you think. Show me what you think. That's fine. All right, ladies and gentlemen, let me see what you did. In 3, 2, 1, show me. Okay, I got a bunch of -4s. That's fine. I got some -3s, but we all put it in the same place. 8 times 10 to a certain negative. So we're getting the first part right. Let's check our counting now. Oh, I may have forgot an extra 0. That might be it. 0.1238. All right. So I know I'm going to take my decimal place. I'm going to move once, move twice, thrice, 4 times. 8 times 10. How many times have I moved the decimal? 4 times. Positive or negative? Negative. Perfect. I'm sorry, I miscounted zeros. I apologize, Adam. That's on me. I led you down the wrong path. Mr. Wiseman is the worst. Let's pick a number that's not on our board. Let's do I want you to write this one down. 7204000. I want you to write that number in scientific notation. So I want us to understand something, and I'm going to see if you guys can figure it out without me. Yeah, I got Justin. Justin comes back out, you got right. I'm sorry, show me what you got. Got it. That's fine. That's fine. What's your power tube on? So I've not taught you this, but I'll see if you guys can figure it out. When we are taking a number and putting it into scientific notation, my new number, I'm only going to write down the significant figures. 1 significant figure, 2 significant figure, 3 significant figure, 4 significant figure. There's no decimal place right now, right? So these zeros don't count. So still moving my decimal place. 1, 2, 3, 4, 5, 6. 7.204. Because the point of scientific notation is trimming out all the stuff I don't need. I would stop writing there. Times power of 6. Because in scientific notation, what we are going to find out is that these numbers right here are all the sig figs in my number. Not something we have to worry too much about today, but it's something that we're going to be doing a little bit more in the future. I just want to give you that thing to see what we're going to be doing. Now, what I want you to do with a little bit of time is I want you to knock out 5 and 6 on your whiteboards. I want you to show me your work for 5 and 6 on your whiteboards. Every time you go into power teacher, that's a long time. There we go. There we go. And oh, my 4G shot is smaller too, so I have 15 less. That's not bad. Speed. All right. So everyone had a chance to answer both 5 and 6. Everyone have a chance to answer 5 and 6? Show me what you got. 3, 2, 1. Let me see what you did. All right. Remember, we're not losing anything in moving the decimal, right? We're keeping all the digits the same. So if I'm looking at number 5. If I'm looking at 5, 5 is 0.025. I want to move this decimal to after the first digit, the first significant figure. What's my first significant figure? The 2, right? 1, 2. Is my new number 2.5? Is that greater than 1, less than 10? All right, so my new number is going to be 2.5 times 10. How many times I moved the decimal? 2 times. Is it positive 2 or negative 2? Negative. Small number always moves to the negative. So the exact same thing with number 6, 0.0025. Again, I want to move my decimal to behind the first significant figure. Which was my first significant figure? 2 again. So I move once, twice, thrice. It's 2.5. Still greater than 1, less than 10? It is. Times 10. How many times I moved the decimal? 3 times. Negative or positive? Negative. Okay? That's the first half of your homework. It's converting standard notation into scientific notation. This is my scientific notation. This is my standard notation. Second half of your homework is that you got to go the opposite way. I'm going to give you stuff in scientific notation. You're going to write it out in the standard notation. And I feel out of the 2, that one's going to be the easier one. Let me get something more like here. So my notes help me figure out how to change to standard notation. If the power of 10 is positive, we're going to move the decimal to the right-hand side to make a big number. If the power of 10 is negative, I'm going to move it to the left-hand side to make a small number. So I start off with number 1. Number 1, I have 1.5 times 10 to the positive 3. Adam, when she signs in, I want you sign out, okay? So, based off the rules posted at the posted on the screen and also on your paper, am I dealing with a big number or a small number? Big number. So which way am I going to move this decimal here? To the left or to the right? Right. We'll move it to the right. So I'm going to rewrite 15. I move it 3 times. 1 time, I've made 15. I move it a second time. What am I going to put in front of my decimal here? A 0. 1 time, 2 time. You know what? It's so nice. Let's move it 1 more time. 3 time. What am I going to put in this empty space? A 0. Why? Because these guys are my placeholders. So my final answer is 15 hundredths. Scientific notation is one of those things is that the more we do, the easier it comes to us. Let's try number 2 in the opposite direction. Number 2 is the exact same thing, but instead of times 10 to the positive 3, it's 1.5 times 10 to the negative 3. So, if I'm going to negative 3, am I moving my decimal place to the left or to the right? What's my rule tell me? I'm moving it to the left to make a small number. All right. I move it once. Now it's 0.15. I move it again. What am I going to do? What am I going to put in this hole right here? A 0. That's twice. It was so nice. We're going to do it one more time. Put in a 0 here and drop off my decimal. So my final answer is going to be 0.0015. If I can go one way, I can go the other way. I'd like for you to try 2 more of them. I'd like for you to try number 4 and number 6. And I'd like for you to try them on your whiteboard. They'll be the last things that we do for today. I'll give you guys some thinking time with it. But I want you to do number 4 and number 6. I'm going to write those numbers up right now so I have them. All right. Looks like everyone's got something written down. All right, ladies and gentlemen, let me see it on whiteboard. To the 3, a 2, a 1. Let's see what we got, ladies and gentlemen. Ooh, they're so pretty. So pretty. Looking good, ladies and gentlemen. Looking good in the hood. All right, let's do number 4 together real quick. Number 4. 3.35 times 10 to the negative 1. So which way is my decimal place going? Left or right? It's going left. How many times is it going left? 1 time. So my new number is going to be 0.335. Everybody see how we did that? All right. 1 times 10 to the 4 power. Ooh, excuse me. Let's write down my 1. Is my decimal place going to the left or to the right? It's going to the right. How many times is it going to the right? 4 times, right? 1, 2, 3, 4. That's all it is, ladies and gentlemen. Now, we will talk about the E function on our calculator, because when we start doing functions, so I'm doing math with scientific notation, if I type in a bunch of things, if I type in 6.022 times 10 caret to 23 divided by 6.022 times 10 caret 23, I'm going to get some wild, crazy number. Because my calculator does not see scientific notation unless I tell it it's scientific notation. 6.022 times 10 to the positive 23, that's Avogadro's number. I divided Avogadro's number by Avogadro's number, and somehow I end up with 1E46. That's 1 followed by 46 zeros. Because my calculator does not see one function, my calculator sees 1, 2, 3, 4, 5 different functions happening at the same time. When we get through going through the rules for how we do math with sig figs, which we will do next time before the quiz, we will show you how you can do 6.022 23 divided by 6.022. So my calculator knows it's scientific notation, and I only have one function I'm working on. That's going to be not next class. Next class is us showing you guys the rules for our different functions with sig figs. That's going to be the day after. So, ladies and gentlemen, thank you so kindly for being here.